Hello friends, I am Chandan. So in last lecture we cover the entropy change for a reversible process, the entropy change for irreversible process, and the entropy change for universe. We see that. Now focus on the TH diagram. Okay, TH diagram basically temperature entropy diagram. Okay, S is basically entropy. Okay, S is basically entropy. So S is basically entropy. Okay, entropy. So here T is temperature. Okay, this is y-axis, there is temperature, and there is x-axis, this is a entropy. Okay, now focus on this point here. This is the point here. In this point, this is state 1 and this is state 2, and the process is happening from state 1 to state 2. Okay, in this direction. Okay, now in last lecture we cover that if you want to calculate the ds, that is entropy change, ds that is equal to del q by t for reversible process. Okay, for reversible process. Okay, so consider this process. So this process is an irreversible process. Consider this process is a reversible process. Okay, now so here so this you can say that dq del q that is equal to tds. Okay, so integrate on both side, okay, so from here you can calculate the amount of heat q that is equal to integration tds. Okay, and this equation is applicable for reversible process or for any open system or closed system. Okay, so if you want to calculate the amount of heat for reversible process, it may be open system or closed system. This is the formula. So q that is equal to integration t ds. Okay, now so what is integration tds? Basically, if you draw a vertical line on entropy axis, this area will be integration tds. Okay, this area will be integration tds. Okay, so this area indicates what is the amount of heat which is transferred for a reversible process. Okay, for a reversible process. Okay, now so we cover that, hence area under the curve on TS diagram is equal to the magnitude of heat transfer in reversible process. Okay, the process in which entropy increases are known as positive area or heat addition process. So we just last lecture we covered that the process in which the entropy increases are known as positive area or heat addition process. Okay, and the process in which the entropy decreases are known as negative area or heat rejection process. Okay, so this is all about the TS diagram for reversible process. Okay, next concept, that is representation of Carnot cycle on TS diagram. Okay, TS means temperature entropy diagram. You know the Carnot cycle. In Carnot cycle, let's try to understand this. So there is a pressure axis and this is the volume axis. So this is pressure, so here this is pressure and this is volume, and this is state 1 to state 2, this is one process. State 2 to, so this is one process. State 2 to state 3, there is another process. State 3 to state 4, there is another process. Okay, and state 4 to state 1, this is an another process. And if you want to draw the TH diagram for Carnot cycle, this will be, this is state 1, and this here, this is the vertical line, this is process 1, there is a horizontal line, this is process 2, and this is a vertical line again, this is process 3, and there is a horizontal line, this is process 4. Okay, so in TH diagram, this is TH diagram here. If the arrow is upside, there is a compression process, and if arrow is downside, there is a expansion process, and if the arrow is right side, this is a heat addition process, and if the arrow is left side, this is a heat rejection process. So from here, so you can say that 1 to 2, this 1 to 2, this is a isentropic compression process. Okay, or you can say that this is isentropic compression process. Okay, isentropic or adiabatic, reversible adiabatic compression process, or you can say that isentropic compression process. Because so for TH diagram, this is, if the arrow is increases, this is a compression process, and this 2 to 3, the constant temperature heat addition process, because for right side there is a heat addition process, and if the arrow is going left side, this is a heat rejection process. So here this is arrow is right side, that is heat addition process, and isentropic, this is 3 to 4, this is isentropic expansion process, because here entropy constant, the S3, that is equal to S4, that is equal to S4. Okay, S4, and here entropy S1, that is equal to entropy S2. Okay, and 4 to 1, this process is known as isothermal heat rejection process. Okay, so this arrow indicates that this is a rejection process. Okay, so here with respect to point 2 and 3, the temperature at point 2, that is equal to temperature at point 3, and temperature at point 1, that is equal to temperature at point 4. So this is isentropic compression process. 2 to 3, that is a constant temperature heat addition process. 3 to 4, that is isentropic expansion process, and 4 to 1, constant temperature heat rejection process. So this is the basics about the Carnot cycle for TS diagram. Okay, so so this is my handwritten notes. You can download it from the description. Like, share, subscribe my YouTube channel. There is a Telegram group, Mechanical Bengali. You can join this group to regular update. So thank you.